Hi students, now the fourth sum in the text exercise. A transistor of alpha gain equal to 0.99 and base emitter voltage is 0.7 volt is connected in CE configuration, that is common emitter mode, as shown in the figure. If the transistor is in the saturation region, that means the transistor is conducting the current in the saturation region. Find the value of the collector current. Now the circuit is to be understood carefully. There is a 12 volt battery here. So the collector terminal, okay, here it is connected to the 12 volt battery and the emitter is grounded. So as usual, now this transistor is NPN transistor in the common emitter configuration. Okay children. So the battery is sending some current through this resistance of 1K. So let this current sent by the battery be I. I ampere current is sent by the 12 volt battery, and that I ampere current first enters through which resistor? The 1 kilo ohm resistor. When this current reaches this junction, you can see here there is a junction. After this, the current is going to divide in two branches. One current which is going to flow through the collector resistance of 1K. So in this branch, the current is denoted by IC. So a certain portion of this current I is going to flow through the collector. That current is called as IC, collector current. The remaining current is going to flow through the base of the transistor. You can see here the base of the transistor. Therefore, the remaining current is taken to be what? I base, IB. That is flowing through the 10 kilo ohm resistor. So, I apply Kirchhoff's current law at this junction. At this junction, Kirchhoff's first law or current law, if I will apply, means this total current I must be equal to what? IB plus IC. Understand? So the current supplied by the battery must be equal to the base current plus the collector current. So at this junction, the collector current will flow through this 1 kilo ohm resistor and it will flow up to this ground. The remaining current I base is flowing through the 10 kilo ohm resistor. Okay, now what is the potential difference between the base and the emitter? Between the base and the emitter, this potential difference is equal to 0.7 volt. So this is 0.7 volt. Now at this junction the current divided as IB and IC, is it not? So the IB is flowing through the base and then it is coming up to this point here. So when the current comes here, again once again this total current will be equal to what? This IB flowing in the left arm and IC flowing in the right arm. So once again the current will be IB plus IC, which is flowing through the 1K ohm resistance. Understand? So here the current flowing through this 1K resistor is the sum of IB and IC. It divided as IC through this 1K and IB through the 10K. And once again, now you can see that the current flowing through this grounded resistance of 1K is also equal to what? IB plus IC. Okay. Whenever current is flowing through any resistor, whenever the current is flowing through this resistor, the current into resistance product will produce a potential drop across the resistor. Understand? So like that here also when the current of I base is flowing through this resistor, a potential will be dropped. And here also the potential difference between the base and emitter is already existing as 0.7 volt. Then once again here when this current is flowing through the resistance of 1K, there will be a potential drop. So if you add the potential drop across this 1K resistor, across this 10K resistor, and if you add with this potential difference and this potential drop, the total potential difference must be equal to the difference in potential between 12 volt and 0 volt, that is 12 volt. Understand? So now we have to analyze the circuit carefully. The current IB plus IC is flowing through the resistance of 1K, is it not? So the IR product, what is the IR product? I am going to write here IB plus IC, okay, IB plus IC into the resistance is how much? 1K, so into 1K. So this product will be the potential difference across this resistor, okay. Then out of this, the current, branch current IB is flowing through which resistor? 10K. So I am going to take only this left arm. So IB is flowing through 10K. So I will write plus IB into 10 kilo ohm. Okay. So this is also a potential drop across the resistor of 10 kilo ohm. Then what is the potential difference between the base and the emitter? It is 0.7 volt. So I am going to add this 0.7 volt plus the potential difference across this 1K resistor is once again IB plus IC into 1K. So this is IB plus, here we have to add, is it not? So this is plus IB plus IC into 1K. So if I add all these potential differences, means that should be equal to this 12 minus ground 0. So that is equal to 12 volt. So this is the first step of understanding in this problem. So for that I have taken the branch which is flowing through the base of the resistor. Understand, sir? So this is the left branch I have considered. Okay, then what else is given, children? You see here the alpha gain of the transistor is 0.99, is it not? So the beta gain, so beta gain is equal to alpha divided by 1 minus alpha. So from alpha gain, how to find the beta gain? There is a formula relating alpha and beta. So I am going to substitute alpha is equal to how much? 0.99 divided by 1 minus 0.99. So this is equal to 0.99 divided by 0.01. So that is equal to 99. Okay. Therefore, so beta is equal to 99. Okay. So this is one expression. But by definition, what is beta gain? Also is equal to, beta gain also is equal to the collector current divided by the base current. So I can express collector current in terms of the base current. So what is this equation implies collector current is equal to beta times base current. So that is equal to 99 times the base current. This relation between IC and IB can be established. So step number 2, what we did, from the given value of alpha gain, we determined the beta gain. So beta is alpha by 1 minus alpha, it is found to be 99. By formula, beta is equal to collector current by base current. Therefore, collector current is how many times the base current? It is 99 times the base current. Okay, children. So now in the first equation, I am going to substitute wherever IC term is coming, wherever IC term is there, I am going to substitute 99 times IB. Understand? So I am going to rewrite the equation. You can now join with me. So this is IB. So first I am writing this is IB plus, instead of IC, what I can substitute? 99 times, okay, 99 times IB into how much? Into 1K plus here IB into 10K. This also can be written as 10 times IB into 1K. I can modify this as 10 IB. Okay, in the bracket I will write 10 IB. Outside I can write into 1K. Both are same, no? So IB into 10K is 10 times IB into 1K. So that everywhere 1K can be taken as common factor. That's the idea. Plus 0.7 volt. Okay. So this is plus 0.7 I will take to the right hand side. I will take it to the right hand side. Now the remaining term IB plus, once again you see here IB term is coming plus IC term. Instead of IC, what shall I write, children? 99 IB. Okay, so this is 99 times IB. So this is 12 minus 0.7, is it not? This 0.7 is coming to the right hand side. So this is 12 minus 0.7. Okay. Now 1 IB plus 99 IB is how much? 100 IB. So here 100 IB into 1K plus 10 IB into 1K plus IB plus 99. Once again, this is 100 times IB into here 1K. Okay, 1K. So this is equal to 12 minus 0.7 is 11.3 volt. 11.3 volt. You add now all common factors, that is 1 kilo ohm. 1K is 1000 ohm, is it not? So 100 plus 100 is 200. 200 plus 10 is how much? 210. So 210 into IB into 1 kilo ohm is 10 power 3. Okay, children? So 210 IB into 1K. So this is equal to how much? 11.3. Therefore, what is IB alone is equal to 11.3 divided by 210 into this 10 power 3. Right side when it comes, it becomes 10 power minus 3. Understand? So I am going to divide. So therefore, IB is now equal to, if you divide 11.3 by 210, this will be 0.054 into 10 power minus 3. So this 0.054 can be written as 54 into 10 power minus 3. So this is also equal to 54 into 10 power minus 3 into 10 power minus 3. Okay, our base current is now equal to 54 microampere. So this is 54 into 10 power minus 6 ampere. That is equal to 54 microampere. So this is 54 microampere. Now what is asked here? Find the value of the collector current IC is asked. Is there any relationship between collector current and the base current? You see here, we have arrived at the value of base current IB. Beta is given. Beta is 99. We have already found beta is equal to 99. So collector current is 99 multiplied by the base current. So the last step is, therefore collector current is 99 into base current. So this is 99 multiplied by 54 microampere. Understand? So if you multiply means this will be equal to 5346 microampere, or this can be written as 5.346 milliampere. Normally we express the base current in microampere, is it not? But the collector current is a large current, it must be expressed in milliampere. So this is the final answer for the collector current. Okay, children? So first we have to do the circuit analysis carefully and correctly. Then from the given information, so step by step if you do means the final answer will be correct. I hope you must have understood well. Fine.